Hello guys, welcome back to my channel. Let's move on and actually apply some more advanced skill sets to our marketing data sets. So today I'm going to discuss about some of the very basic predictive techniques that we do use as a data scientist in order to predict a value. So yeah, the code is such that let's make data-driven predictions in marketing, where we take data set and based on that data set we will predict the market, will predict the outcomes here. So predictive analytics uses historical data to forecast future performance in marketing. It help us to answer the following questions like which customers will likely to spend more, which campaigns will perform better in the future, or based on the customer demographic, like which is going to give us a better result. So in order to do that, we are going to build a linear regression model. If you are not actually familiar with linear regression, I suggest you to go and watch my linear regression video where I actually discussed this topic in more depth. So we are going to build a linear regression model that will take two input arguments, the age and subsequent order count, and it's going to predict the profit based on those two customer demographics. So in order to do that, we will first like to import the relevant libraries. In our case, first one is obviously the pandas. The second one here, I'm importing linear regressor in this particular statement here from the module linear model for sklearn, which is kind of a very robust module in Python that allows us to perform some statistical method, even some prediction method as well. Finally, we would like to visualize our results with the help of matplotlib. Now, in order to build a linear regression model, first we would like to have our predicting variables which will be used in order to predict the output variable. So in our case, the predicting variables are column age and subsequent order count. So here we have separated those values and stored in the variable x. And then we have like target value which we are going to predict. In our case, we have total profit that we are going to predict. Now, once you like separated those values, you are going to first of all create an instance of the class linear regressor and have an object being stored in model. Once you have that, you are going to apply its method fit, and you will pass two input arguments. The first input argument is actually the predicting variables, and the second input argument is actually the value that how needs to be predicted. In our case, y. And once you have that, we will with the help of this statement, we have successfully built a simple linear regression model that has the following characteristics. It has some intercept value, it has some coefficients associated with it that represents an equation of linear regression. Now, once you have that, what you are going to do, you are going to predict the value based on the input. You will pass the input and arguments, and that will predict the value, and then we, after predicting those values for all x, we are going to store it in a new column called predicted output. Now, in order to plot a beautiful visualization in such theoretical scenario, I'm only going to take some 50 values from that data sets. Once I taken those values, I have like a new data frame created called subset that has also this column predicted profit, and that has also a column called total profit. So what we are actually going to do here, we are sort of creating a scatter chart between the predicted profit and actual profit, and here the red line actually represents a very 100% accurate prediction by the linear regression. So the dots that are close to this particular line is a better prediction as compared to the dots that are away from this line, which represents a bad prediction. So what we actually learned in this particular example, machine learning can quantify relationships like how age impacts profit, which can be like interpreted in the form of these intercepts, coefficients, and R square value. Linear regression gives you the direction and magnitude of effect. So here's the thing, like without actually having to deal with the prediction, it also gives us some valuable information like where the direction is heading. Like if we increase one variable, well, will that increase another variable? So it's kind of give us the relationship of uh, predicting variables with the predicted value. This is like just the basic concepts and basic techniques. Obviously, there are more robust techniques at hand. Even the linear regression itself can be modeled in such a way that can give us more robust answer. So that's it for today's video, and I'm going to catch you soon in the next video.